Howdy everybody in YouTube land. The first installment we dealt with purely the logic board. This installment, after taking out a whole bunch of screws, we ended up like this. So I didn't get that on camera because quite frankly that's not necessary. Anyways, you can really see the tin whisker syndrome. This thing must be zinc plated because look at that. That is bad. It's like fuzz. Yeah, I mean, yeah, I gotta clean all that up. Definitely. Because that kind of crap would hurt this thing. But anyways, that's beside the point. First thing I want to take a look at is I got the power supply out and I got the analog board out. The power supply is for later. It is a Sony model CR44. So we're going to save the power supply for later. So right now I want to focus on just the analog board. Quick overview of the analog board. Inspect for any anomalies. Some hot glue there, that might be normal. Unplug all the unnecessary crap you don't need. So right now I've got the neck board out and I'm going to remove all those. And next thing we're going to do is after that, then I want to inspect the soldered joints to make sure they're not cracked, because these here, the yoke connectors, and you can actually just start to see it. The yoke connectors are a common problem. The flyback connections are a common problem, and these guys down here are a common problem. Matter of fact, that one looks cracked too. The one on the far end, it is cracked. So is the first one. And then the rest of the connections need checked and resoldered too. So to make sure that I have a good joint, I'm going to, since these connections aren't burned, if these connections were burned, then I would suggest removing the solder and redoing it, but they're not burned, so I'm just going to add a little bit of flux, heat them up, and then of course add fresh solder and repair all the solder joints on this board before I move into replacing the capacitors. So after that, then we're going to replace the capacitors. And inside that bag is a whole bunch of them for this board. And here's the thing with capacitors. Most people will just buy whatever. But I strongly recommend, and this is just for aesthetics reasons, I recommend purchasing the ones that have the correct pin spacing and height. And sometimes you won't be able to find the exact heights, but you'll definitely find the ones with the correct pin spacing. And replace axial with axial. Now, my logic board video, you've probably seen the one that is not an axial. It's a radial cap, just kind of laying down here with the lead spread out. That's because I just didn't have one. And that one's buried up under there, so it's hard to see anyway. But this one here is important because it's going to be the most easily seen. But as long as the back's not off the machine, it doesn't really matter. I mean, you don't have to use axial. I just like to, because that's what was there, what was used originally. I mean, no big deal. It's just your prerogative. And I'm going to take this out, and I'm going to use a film capacitor here. Now, the film capacitor, the lead spacing, I couldn't find that exact. The only ones I could find, the lead spacing is out to here. So what we're going to do is we're going to drill a couple of holes in the board and make new lead holes. And you'll see that a little bit later. But for now, I'm going to go ahead and start touching up solder joints and getting the capacitors replaced one by one. Well, now that that's done, it's time for some recapping. Alrighty then, there's all the caps but one. There's all the old ones. And then actually, I think this is the worst one of the bunch. It just started to leak. So that was the one that was right here. Anyways, I really need to practice what I preach because, well, unfortunately, I was short one axial leaded capacitor, so I had to use a radial. But hey, at least I had one of them. Anyways, the next thing in the installment is I have to figure out how to make that mount in that place there. And there's a way to do it. And the way that I'm going to do it is use a little bit of drillage by basically drilling a hole here, or actually I might even start there and drill a hole down here so I can get to fit. It's not going to fit in between a space. It's going to sit up a little bit, but at least it'll be in there properly. Unfortunately, I had lost my drill bit to do this, so I'm going to have to take the more hackish approach, which is stick one lead through the hole and solder the other one directly to this jumper wire. It is what it is in this case. Okay, well, now that wasn't so bad. Just tacked it there on W6 and then soldered it up underneath it. And there it is, all new caps, and things have been resoldered. The next thing up is the power supply, which is right here. So let me get busy getting all these screws out. The way these Sony power supplies work is you have to loosen the two screws here on the side and all the way around it so you can lift it up on this end and actually slide it out of the grooves down here. So once you have those slidden out of the grooves just like that, you should be able to easily remove the lid. Now, this is the inside of the Sony power supply. Now, granted, there's some pretty high quality capacitors in here. This big K gives it away that they're using Rubicon brand, so spared no expense in the design of this power supply, which is probably the reason why it still works to this day. However, even though this power supply is now, 89 to 09, so like 16, 17 years old, somewhere in there, I don't know. 89 to 09 would have been 10, or 89 to 09 would be 20. Wow, where did I go to take math? Cracker Jack box? Anyways, so from 89 to approximately 2009 would have been 20 years. And then from 09 to 2016 would be roughly 7 years. So this thing is 27 years old. Holy crap. See, it should be around 25, 26, somewhere in there. Anyway, roughly 25 to 26 years old. Do the math, because I apparently can't. Anyway, 1989 date code on that chip there. Let's see, we've got a hybrid IC over here. And God, pray the soul if that thing ever goes bad. And let's see, yep. We've got our optical feedback network somewhere in here. This power supply may not use them. It's hard to say. Anyways, let's get this thing out of the cage and bring it some more light. And the easy way to do that is to take this screw out here. There's a screw there, and then there's one up here, and you have to take this screw out here, which holds this rectifier diode in place. And then as you remove the device, you need to pop this cable out here and make sure that this is not glued in any place, and it should come right apart. And it's out. Now, careful, try not to lose this cell pad, or you'll blow shit up when you put this thing back together. This one had a little bit of glue on it. It was held down right here, but aside from that, I'm not seeing anything painfully obvious as far as leakage or damage, although one could never be too sure. There's a lot of flux residue collectively. Anyways, the power supply was working properly, so it's safe to assume that we can just go ahead and replace the capacitors. Now, this capacitor here, most people don't replace these because they very rarely ever go bad, but they do go bad, and I have seen them go bad. But because this is a full restoration, we're going to change this capacitor anyways. So we're going to change every single one of these. We're going to change that one, these two, and all the other ones. But this one, because my drill bits aren't here, I couldn't drill the holes. The capacitor that replaces this is not the exact same footprint, because look at it. It's a very weird footprint. So what I have to do in the case of this power supply is, in order to fit the new capacitor, and actually, you know what, I'm going to go ahead and open it up and show you what it looks like. This is the replacement. It's a standard snap, 680 microfarad, 400 volt. But as you can undoubtedly tell, the footprint is not the same. So what I have to do physically is use one of these slots for the anchor for one of these pins, and I actually have to drill a hole in the copper for the other pin to come through. But again, unfortunately, I don't have the drill bits here for that, so unfortunately I'm not going to be able to do this capacitor today. I will do this in another installment. Otherwise, I'm going to go ahead and replace all these other capacitors and get those out of the way. Alrighty then, now that we have all the new capacitors installed, except for one, which is this big monster here. The only reason why I don't have it installed is, again, I don't have my drill here to be able to do that. It's at work. So actually, these hardly ever go bad, so I'm not even going to change that right now until I need to. So I'll just keep this one handy just in case I need it, because I will eventually. It's just a matter of time. So anyways, there's the big pile of capacitors that came out. None of them were really leaking except for one. You could just see it starting. And there might be a couple of others in here too, but anyways, so now that we have the power supply recap, we're going to go ahead and put it back together. Now, I will say it's been a few weeks since the last video that I did on this. So it's going to be fun digging up all the screws, because I've done a lot of other work through on this table since then. So now it's just a matter of putting it all back together, except for the hard drive and floppy drive assembly's got to come out. Which the hard drive itself is still good, but well, for now it's still good. But I'm going to pull it out and replace it with something different. However, the main floppy disk drive will have to come out, and we'll have to lubricate that. But so I'll be back again with the floppy drive repair after I get all this back together. The last step in the refurbishing restoration process is to restore these drives, and this one is quite dirty. So definitely going to have to blow this one out before I get started. But before we go any further with this drive, and what I mean by going further is all these grease points are dried out and they need relubricated. So I'm going to lubricate every part in here. Relubricate the ejection mechanism. Lubricate all these pins, slides, gears, all this stuff, which I've covered in previous videos. So I'm not going to go get into too much detail here. But before we even start this process, the first thing I want to do is inspect the read-write heads. And what I'm actually looking for is, if I can actually get in here, is whether there's a flat spot, the head gap wear. And I don't see any. It still looks nice and round, which you can't really see on camera. But it looks flat on camera, but in reality, it's actually got a round spot. So... And that's what you want to look for, is if it's not round, if it's worn flat, or the head gap is starting to open up, then you don't even want to touch this drive, because no matter what you do, it will not read and write floppy disks. So there's no point in even going further. So now that I know the heads look all right, at least it's worth a shot to go further with this drive. So I'm going to go ahead and clean it up and blow it out and relubricate everything. Oh, before I go any further, there are some capacitors on this drive. So there's a couple here. There's one hiding down in there, and there's some up front. Oh, don't get this the wrong way. This really, I mean, I got a whole bunch of capacitors that I pulled out of the boards. I mean, don't assume that this is a repair video. It kind of was, because the logic board had some issues, but they all have known issues. However, this was not, as far as the analog board and power supply goes, this was not a repair video. This was actually more of a preventative maintenance / overhaul video. Just going and changing a whole bunch of capacitors usually is not going to fix an issue if you're having an actual electronic issue. Sometimes it's related, which is how this got started, but sometimes it's not. So really, you really want to do some thorough troubleshooting if there's an issue with the electronic circuitry. So it's always best to troubleshoot and then start changing capacitors if that seems to be the problem. Now, in my case, the logic board in the earlier installment had issues with leaking caps and destroying traces, and that's a known issue, and the problem was evident right away, so that could easily be fixed. But while I was in here, I figured I'd go ahead and restore the power supply and the analog board, and make sure everything is good. So now it's time to overhaul. Now, I'm not going to go ahead and change caps in here because I don't think they're going bad, but you never know. If they exhibit any symptoms, we'll change them, but otherwise I'm going to leave them alone. So basically, to reiterate, I'm going to lubricate all of these slides, pins, guides, levers, all that fun stuff, and I'm going to pull this motor out, which has got a screw here and a screw here, and lubricate that. Because if you don't do that, what happens is the grease gets hard and it puts unnecessary strain on the motor. The drive gear that's on this motor is very brittle, and it will shear all of its teeth, and the eject mechanism will not operate anymore. You'll just get a bzzz, and then nothing happens. So, best to avoid the damage while you're ahead. Now, there is a guy that is making reproduction gears for this motor. It's 3D printed, high resolution replacement gears, and I have ordered some from him, and they work perfectly fine. So you can fix it if you've already sheared teeth without sacrificing another drive. The kit to fix this is available now, so that helps a lot. But we're going to avoid that situation and go ahead and just fix the drive so it doesn't happen in the beginning. Let's see, these pins are bearing loaded, so I got to get some stuff in there, and see some slides down in there that are nice and dirty that have to be lubricated. Yeah, this is going to be fun. Be back in a jiffy. And there we have it. Everything is now lubricated. You can see the fresh oil on there now. Cleaned all the old grease off. The most critical areas is here, which I have a little bit too much there. That's the most critical spot, along with this, because this is the floppy release and drop. So that's the most critical area. And then up here is the slide mechanism for the ejection. So, in order for things to work properly, So everything slides perfectly now. And I already pulled the motor out, lubricated it, everything's good there. So, that's it for the floppy drive. The next thing is the hard disk drive, which I'm just going to replace it. Like I said, the drive I know is going to go bad if it isn't bad already. So I'm just going to save the headache and pull the damn thing out and replace it. So yeah, that's it. And then we'll just put the SCA solution in there, and that's going to be our drive. So that wire for the activity indicator is probably going to have to be extended, because the one that's in here I don't think will work properly. But we'll see. So, this drive's all cleaned up, ready to go, and that should do it.